Hello class. So weekly update, I don't know, maybe 7. So you just finished module 3, getting started on module 4. So many announcements this week. I'll try to talk quite fast to get through them. So midterm grades are coming soon, and be on the lookout for those. Chloe and I are coordinating on getting those to you guys. Many thanks to several folks found some errors last week in the global extremer practice. I think that was like pages 264, 65. Sorry about that confusion, which is why I made that video, global extremer review video. Lots of good examples in there. So if you're still having trouble with that, go check out that global extremer video, which is at the end of module 3. And so the folks that helped on that were Haley, Sam, Charles, Corbin, and Lucas found some errors that time. So bonus for those folks for finding those, and hopefully it wasn't too confusing for y'all. In general, also a couple comments that if, I think you'll notice in OAKS that I don't have end dates on assignments. So I have due dates, but not end dates, because I understand some things happen. Sometimes you have to turn in something late. And so you will get some credit if you turn in something late. Remember our philosophy. Chloe and I both are interested in understanding and mastery, and you know, we'd rather you take an extra day or two or a few, depending on the circumstance, to turn in something, letting us know that you've used that activity to understand, rather than just sloppily putting something in or just taking a 0 and not even attempting an activity. So again, they're all designed to help you get there to the end and not even really have to study for a final exam. Just feel so certain in what you've done and confident in the material and how you've learned it. As the syllabus said, also we have Sunday and Wednesday due dates. Again, typically they've lately been Wednesdays, but Sundays are, sometimes I'll do that if it's to sort of help you budget along that week. So just be on the lookout for those. They should show up in your, and remind each other if you notice, like, hey, here's a Sunday one. Another comment is I noticed from some questions, and then also not everyone's watching the videos, and that's fine if you can pick up what you need from the journals. But sometimes if you have a question, ask a teammate, ask Chloe or I. But many times that information's in a video that you just haven't taken the time to watch. So please do those as needed. Let's see, what else? Oh, okay. So optimization part 1. That was a well, I'll say that when I first looked at, say, the first, 10 or 15 of them, I was really kind of disappointed. They felt kind of hand-wavy, some of those explanations of what your strategies for solving, finding the point on the plane closest to an origin for that particular plane, and then, any plane in general when we expand. And the reason that some of those early ones seemed sort of hand-wavy, it was just kind of things like, oh, I'd take some partials, set them to 0, I'd get some CPs, or I'd look at gradients. But it wasn't clear that, again, this sort of hand wavy, like, oh, I just kind of do this kind of stuff. I had a professor used to use that phrase, and I like it. It kind of is appropriate. Because, again, it wasn't clear that you actually understood and thought hard about that problem. But then I got excited. There were several ones that sort of made me feel better about the assignment. So I put those in the samples and examples, module 3, week 2. And these might help you because you have to do part 2 of that problem. Optimization part 2, where you actually solve it. And so if you were one of the folks that felt kind of hand-wavy about what you were doing and weren't so sure, you might want to check out some of these. So I really liked, let's see, Jenna made a video and Lucas made a video. Those two were really helpful in my thought process on what they were thinking. We had some neat ideas. And in fact, I think Lucas was the one that clearly explained how you get a point on the plane. So I think some of those first ones that I was a little disappointed with, it wasn't clear that you understood how to get a point on the plane. So if that's the case for you, watch Lucas's video. Michael had a really nice explanation as well in his thought process. Lily did a nice job. And then several people came upon the perpendicular property that, like, yes, it has to be the case that from this plane to this point, the nearest one would have to be perpendicular. So we just have to figure that out. And that was, I think, Jenna, Michael, Corbin, Dallas. I feel like Ethan and Charles got to that too. That, yeah, it has to be perpendicular, and then you're a matter of, like, where do I, the perpendicular vector is the normal vector, and I could slide it all around, and where do I get that? That would intersect the origin. So I'm looking for, oh, and that was neat too. Charles and Ethan gave us a preview of something we're gonna learn, and I put theirs, I believe, in there, in the samples and examples. Something we're gonna learn in the very beginning of the next book, book 3.5, is parametric functions. So we will know how to get the equation on this line in terms of parametric equations. And so you're looking for the line that goes through the origin and touches the plane, and what point it touches the plane. And that's easy to do with parametric equations. But you can also do it now with optimization. This is a constrained optimization problem. And a couple of folks said, oh, we already have the constraint. I think Sam did a really nice explanation and write-up. And oh, and by the way, the folks that did challenge number 5, which was, oh yeah, that was Little Boss's group. Little Boss, Ethan, and Dallas, and then Zach, Charles, Christian, and Colin. So those 7 people, Zach, Charles, Christian, Colin, Ethan, Lily, Dallas, I'm sure that they can help you with optimization part 2. So because they did challenge number 5, which involved very similar, but rather than a plane, they had a cone or a paraboloid, and they were trying to get a nearest point on that paraboloid to another point. So very similar problem. And they tackled that, did a great job on challenge 5, both those groups. So they're well set to finish the optimization problem. And then a couple other ones that were kind of new and outside the box. I really like Lee had an interesting idea about making a whole new coordinate system within a cube to find this point. Christian had a visualization idea of like, here's the plane, here's a point, and I'm going to like the points at the origin. And so I'm going to actually make a sphere around the origin, and I'll just keep blowing up that sphere until it touches the plane and figuring out, but still you have the issue of figuring out what point that is. It was neat visualization. And then I also like Colin's idea. Colin had a neat idea of, a lot of people said, okay, well, I'll just pick a point on the plane. Some of you, again, don't know how to do that. So check out Lucas's video. How do you get a point on the plane? And then another point, another point. And so many of you said, oh, I'll guess and check and just pick points on the plane and measure the distance. And definitely a straightforward, will work, just if you have enough time and level of accuracy. But Colin added a new thing, was that he was going to then do that sort of guess and check, but then average the points, which I thought was a neat extension. Okay, so optimization part 2 is coming up this week. Again, if you're having trouble, check out some of the folks I mentioned, and go into the samples and examples and check out some of the assignments that have a nice setup for that. Okay, then the challenges. Those were really fun this week. So even though I was a little disappointed with the optimization part 1, the challenges were super fun. You guys did a great job. And just to point out, I've already mentioned a couple that did challenge 5, and then many folks did challenge 6. So Grace and Jonathan did a nice job. Let's see, Joe, Filippo, Brianna, really nice graphic design and visuals of theirs. Hallie, Nate, and Jeff, as usual, I feel like you guys just do really nice teamwork. I mean, that seems to be apparent in your write-up, and always a thorough understanding, very succinct, clear writing. So I appreciated that. And then a few that really stand out, I think, were Group 7, that's Lane, Sam, and Jenna. Very nice visualizations and level ups, and maybe I'll show you a few of those in a moment here. Group 9, Lainey, Lee, and Brianna. Lee did quite a bit at the end with the level ups, and he talked about having snowboarding, and sort of took that perspective and put everything in context of like, actually, if I was snowboarding and I'm trying to find these particular points on this, I think that one, excuse me, level 6, you had like a sine function going through that terrain. And so very nice visualizations and discussions of that. And then group 11 was Emma, Ellie, Nia, and Shreyas. Also, I think they did every single level up. Really nice job. I'll probably show you some visualizations because nice work there. And then the last one I want to mention is the Team 12, the Pirates. And they made their own pirate ski resort, had a pamphlet and everything associated with it, and a little pizza pie for the winner. So that was Eddie, Kyra, Michael, and Cameron. Excellent discussion, excellent visualization, got to the correct answers. And that was neat to see. So I felt like by the end of those challenge problems, whether you did 5, you really understood optimization. If you did 6, you definitely understood gradients and rates of steepest ascent and descent, and then restricting that to a path through that surface, which helped with the visualization as well. So I'm going to show you a few, share the screen here and show a few that I really liked that had nice pictures. Okay, so we'll look at group 7. This is Elaine, Sam, and Jenna. And we'll go to challenge 3. Okay, so here's their visualizations of the graph from different angles, and then the contour map over that restricted with the gradient vector field. Oh yeah, this is the part I liked. I think I liked the very clear, I think Sam mostly working on this level 2 level up. Again, if you're having trouble with understanding optimization, taking these steepest points, he's going through step by step, showing you all the points that he found. There are a lot of critical points for that particular function, and then highlighting which ones would be the steepest. Excellent write-up too as you go through that. So shoot an email to those guys if you want to see their work. Hopefully people will be willing to share. Okay, then another one was group 9. This is, oh yeah, John Tate's. It's like my John Tate's and everything. This is Lainey, Brianna with an I, and Lee. So I think this one had, oh yeah, some really nice visuals in throughout, but then particularly in the level up. So this would be, I think they did every single level up too. We get to the final report here. Okay, yeah, so yeah, John Tate's in the making. Okay, so here we go. Same visualization, same surface, showing their work of checking these gradients at these different points. Oh yeah, this is the visualization of that. They put a lot of work into this and really nice showing the ski course. This is the resort right here, and then all the gradients that they put on. Really nice job of using CalcPlot 3D to its like fullest to show you all these things. Always labeling their figures. Let's see, and then they have some little green. They overwrote that with the green here, the path of steepest descent, and how it would try to like kind of throw you off as you're skiing through it. You want to buck you different ways, which also I feel like Emma, Ellie, and Mia Shreyas group did something very similar. And we'll get to there. Oh yeah, and then they show where they think the guardrails should be. Again, really nice job overlaying on top of the visuals. Oh yeah, then they get to the, so not many groups went this far with the level ups. And so this is, I believe, mostly Lee this time working on actually getting the curvature. So he knows how to do curvature using, that's probably something you saw back in Calc 1. And for that particular function, the cubic, I think that went through there, he gets the curvature and then starts deciding where its maximum curvature along there and comparing that to the things that Brianna had done earlier, which is nice. Again, just keep going back and forth between the different levels up. And then he went all the way to the sine function at the end. And then this is where I thought was really cool. He starts talking about like what he knows about snowboarding and how his results either do or don't make sense with that, and some interesting observations that he made as a result of that. Again, if you did those levels up and you want to talk about it and you're in another group, email folks and chat about them. Okay, one more, I've got 2 more. Group 11, this is Emma, Ellie, Nia, and Shreyas. Nice visuals again. And really nice, similar to the other group where they worked out the optimization problem of finding the steepest point, taking those derivatives. Okay. And then they talk about, well, they got an idea visually, and then they started going back and checking things by hand. They show the ski course on here. This time they used Wolfram rather than CalcPlot 3D. meeting, where to put the guardrails. Okay, yeah, this was the picture I like. So this was at 10 equally spaced points along that cubic ski course. They went and got the gradients, and again, notice that it's always like sending you to the outer curve, so you want to put the guardrails on that side rather than the inner, because no one's going to fall off the this side, they'd be sailing off the outside. And then also talk about the length of those, has some meaning, and what would be the steepest. Yeah, so those pictures I really liked. One more, or maybe two more. Group 12, this is, oh yeah, this is our Pirates group, Eddie, Cameron, Kyra, and Michael. And I really like how they back and forth and put their notes and figures in the beginning, where they're just brainstorming section, and then they clear things up for the report. And just always this team, beautiful reports, just, you know, from the introduction, methods, conclusion, the writing, the setup, the figures. And this is the one where, again, they sort of set up this pirate ski resort, Charleston's newest and only premier mathematics themed ski report. And they talk about like putting it in context of not just that steepest point and where it is, but like just how bad that is. Like you're just free falling down into, which shows I just kind of made up these functions. Huh? I could have picked something, tried harder to pick something close. I'd never skied that. So I was excited to see how much from the true skiers that maybe this kind of made sense. Okay, so again, nice visuals where they've overlaid some particular points. They talk about their initial guesses, where they thought it was steepest, and then what the math actually showed them, and then confirming which parts make sense. And they went to a level up as well, showing all the calculations there. Okay, and then one more, because I like one particular figure, and this was group 8. This is Joe, Filippo, and Brianna with an E. This particular figure at the beginning, okay, I really like this. So they went and showed the entire surface, and then they're like, but this is just the part that the ski resort owns, like this section here. So I just like that they showed us the full function and then restricted over that particular domain. It was a neat visualization. And they do also, this group always does a nice job labeling all the figures with captions. I like that italicized font there. And the graphic design matters. And if you took more classes with me, especially when we get to my higher level and graphic graduate level classes, you have to do those sorts of things. Great, again, this one, just really great visuals throughout. And then the explanation was just short and concise, but they had what you're looking for. It was along that group that everybody got Y equals 1.5. Okay. One last thing. So this week, your discussion is trying to, if you need help with finding a study buddy, so it's an optional one, but I do want to point out that don't be like me when I was younger. So once upon a time, I was a baller. So in college, I was the point guard on our basketball team, and we were the southernmost team in the Northeast Conference, which meant we had like 10-hour road trips to get to our games. And so I was missing a lot of school for basketball. But all that to say is, like, when there was group stuff, it almost always felt to me like a hassle. And we didn't have technology and didn't have these phones or Zoom or anything. We still don't have one of those smartphones, but it would be much easier for y'all now. And I know we have several ballers in this class. We got a footballer, baller, and a baseballer. So folks and other folks traveling and working and everything, it does make it seem like imposition sometimes with the group work, but I've noticed that you've done a really good job with those Google documents and making the Zoom meetings. And so I was saying, don't be like I was then, which felt like, what was I getting from this? It was like more of a hassle, where by the time I got to graduate school, though, I had gone to a small college. And when I got to graduate school, I'd be in these classes and teacher would be talking about, you know, some probability method or something. And I'd look over at my friend Emily, who went to UNC, a big college, and be like, have you even heard of that? You know, and she'd be like, oh yeah, that was towards the end of like our probability class, our probability book. And I thought, in many ways, we would only get, because we were such a small college, like there's like 2 of us in my graduating class that got math degrees, sometimes a class of 4 people. So they were teaching less to like to finish the book at the top. So anyway, long story short, we might finished half of that probability book, whereas Emily had finished the whole probability. So I was feeling behind. And in the first year of graduate school was tough, you know, having to catch up. And we all come from different backgrounds, different places. So I just knew I needed to get some catch up. And so it was really nice then to have those group things. Now I was the one that was like, this is valuable, I need it. It's not an imposition. But I started learning too that regardless of where you feel like you are at in the group, you're all giving and contributing something. And had I had that mindset in undergrad, I think it would have been a lot more efficient and fun and enjoyable. Because even if I felt like, oh, I was the one that knew everything, by explaining it to someone else, that's already studying for the final exam. I totally would get it. And they'd ask things that would make me like turn my head and think about something in a different way. And it wasn't until graduate school that I really learned the value of that. So don't be like young Amy, be more like, you know, the wiser one. And take advantage of this opportunity to connect with someone this week in the Study Buddy discussion board assignment. And one other thing from graduate schools, I remember, so in some of these groups or in class, sometimes, you know, I was directly out of undergrad and grad school, but sometimes you'd have some folks that had been working for a while or already had a couple degrees. And so one of those folks was Jennifer LaFoe. She was a bit older than us. She was probably 30 at that point. So seasoned and understood and had been a good student. And so working in a group with her, I really learned to appreciate, like, start asking questions like, well, how did you do that, Jennifer? Like, how did you get that? And sort of, instead of thinking like I couldn't maybe get there, it was like, well, trying to ask, okay, well, she has this level of understanding. Well, how did she get to that? Like, how did she know to ask that question? How did she think of it that way? Start maybe thinking more like meta math and doing that in your groups this week. So like, for instance, if you watch the videos that I mentioned from Jenna and Lucas, and it's like, if you say, well, how did they even come upon those ideas? Like, well, ask them. Like, how'd you do that? Like, where did that come from? You want to understand ideas. And I think the other thing I should say too about that optimization part one, where I was a little disappointed in some of the work that was turned in. I think it's a matter of, you know, I think you're busy, you just didn't give as much time. And, you know, people would ask Newton, well, how'd you do all this stuff, Newton? And he would just be like, well, think on it continually. Like, if you give it the attention it deserves, and we can all do this. We all have the ability to solve these problems. And if you feel like maybe you're not there where one of your teammates or classmates is, again, start asking, like, how are they doing this? And some of it's just a matter of like vocabulary knowledge. Okay, you got to catch up. But other times it's a matter of just how you think about problems. How do you get the confidence to again, like, be creative, think outside the box, turn your head and look at the problem a slightly different way and look at it this way. And so ask your teammates that, like, start thinking about how to get there. So working with Jennifer LaFoe really taught me that, because she also, sometimes we'd be working on a problem for our homework and we get it and it was like, okay, well, I just wanted, okay, we did number 2, let's move on to number 3 now, just being like efficient. And somebody else would say, well, I did it this way. And she'd be like, whoa, let's go back to number 2. I want to hear what Jim thought, how he did it. He also got an answer of 3, but like, how did he did it totally different than what we just did. And I'd think, well, I understood what we already did. Like, I didn't want to be overwhelmed by like this other way of thinking about it. But she's the one that really had this idea of, like, you know, idea of that learning it was like a diamond with different faces, and we had to look at as many different faces as we could because we'd get greater understanding that way. The other odd thing I will never forget about Jennifer LaFoe, she was from Louisiana, and she would sneeze no less, when she sneezed, no less than 7 times. And on average, it was like 9 to 10 times. She'd be in class and you'd hear this, like, and there she'd go. It was like, so I started counting them. It's just incredible. Like, I've never met anybody, like 3 or 4 for me. That's a sneezing, but okay. Well, anyway, that was the end of all the comments for this week. So I hope you have fun with, we are halfway through already. Module 4, you're almost done an entire journal. On to our next one, which has some really cool topics in. So have fun this last chapter. It's also very visual. I think it'll be very straightforward. There is some technical part when you're doing some double integrals, but I think you'll enjoy it. Okay, have fun and keep asking questions. Shoot me emails.